begin, we will launch Packet Tracer. And in Packet Tracer, we always have to pick which device do we use in our virtual network. And we start with routers. It gives us several models. We're going to pick the 2620XM or the 2621XM, whichever one we prefer. I prefer the 2621XM. So here's one router in network A, one router for network B, and one router for network C. Now, we will name him properly, so we click on him and we go to the configuration and we can now name him. So we're going to name him network A. And we're going to name him router A. So we know what it is. We're going to do the same thing over here for network B. Click him, go to the config, name him network B, and name him router B. Last, for network C, we name him network C, and we're going to name the router device router C. Now these routers do not have any wide area network interface cards. When we first drag them in here, and in the next step we will add them to the routers. In order to add the wide area network interface cards, we have to double click this router, go to the physical tab, and power him down. Then we add a WIC, short for wide area network interface card, into each of these slots, so the router at network A can connect to networks B and C. Then we power him back up. We repeat this for the routers on the other locations. We power him down. We add the wide area network interface cards and power him back up. Last over here, power him down, add the two wide area network interface cards, then power him back up. And that's how we now configure these routers with WIC, so they can actually connect remotely. We will now add a switch to each location. So we click on the switches icon here, and we will select the 2960 switches, one for network A, one for network B, and one for network C. And so we're going to bring them a little closer together so we don't have it too crowded here. Then we're going to change the name, of course. Again here, this is network A, switch A. We cannot leave the space there. So there we go. We do this here again. Make this network B. switch C. God in heaven. We need these switches so that we can connect computers to the routers, as we do not normally connect computers directly to routers. We will now add computers to each location. To do so, we will click on these end devices icons, and as you see, there are all sorts of different end devices you could add, from IP phones to laptops to regular desktops. We're going to select desktops. We're going to add 2 computers to each locations. So 2 for network A, 2 for network B, and then 2 for network C. We will change the names like we did with the other devices, but double-clicking them. Going to config, and we will name them network A underscore PC1. We will name him network A PC2. And we will name this one here network B PC1. This one here will be network B PC2. And we will repeat these steps over here for network C. So this one will be network C PC1. And the last one will be network C PC2. The next step is to connect all the devices in each location. In a LAN, one location, we typically use Ethernet cables to connect these devices, and so we click on the devices icon, and this is a straight through Ethernet cable which we use when we connect devices that are not alike. So we click on the device, click on the router and select the first Ethernet port there, the first NIC, and click on the switch and select the first network interface card there. We repeat this to connect PC1 to the switch, and that also connects it then to the router. And we do the same thing for PC2, connect it to the switch, which then also connects it to the router. As you see here, as soon as you connect the computers to the switch, the ports on the switch turn amber and they will become green, and the connection at the data link layer is made. This is different from the router, because the router, we have to manually open up the Ethernet port. By default, it is shut down. All interface cards, wide area network interface cards, as well as NICs, everything is shut down. Now we're going to do the same thing for network B, so we're going to connect the first Ethernet port on the router to the first Ethernet port on the switch, and connect then the first PC to the second port on the switch, and last but not least, the third device here, PC2, to the third port on the switch. So now they are all connected. We repeat these steps for network C. First Ethernet port, the first port on the switch, then PC1 will be connected to the second port on the switch. Last but not least, PC2 will be connected to the second Ethernet card, third Ethernet card on the switch, and everything is now connected in each location. In the next step, we will now connect the 3 locations. Note that the connections between the PCs and the switch are now active. They are not configured yet, but they are active at the data link layer. And in order now to connect the routers, we will now directly connect them. Therefore, we need to provide timing or clocking on one side of the connection. So we click on this. This is the white arrow cable we will use. So we're going to add the clocking to the serial 00 and the non-clocking to the serial 01. We're going to repeat this here. The clocking to the 00 and the non-clocking or non-timing to 0/1, and the last one here, clocking again to 00 and non-clocking to 01. So now everything is connected, but of course we will now have to configure it and open up the WICs or wide area network interface cards and the NICs, the network cards on the routers, so that everything can speak. We will now configure the routers, and first we will open up the connection to each local area network. So I'm going to click on the router for network A. I click on CLI to get to the command line interface. I say N here. I don't want to use this mode. I press enter until I get a prompt, and I have a prompt with an arrow pointing to the right, which is user mode. It does not allow me to do much here, so I use the enable command, which takes me to privileged exec mode. I still cannot configure anything here. I can look at things though, but I still cannot configure anything here, so I say configure terminal, and that puts me in global configuration mode. I didn't mistype this, so configure terminal. And in global configuration mode, I can give the router a host name. If I work with multiple routers, it helps to know which router you work at. So I'm going to name him router A. So I know I'm working on router A. And we will disable DNS lookups in case we mistype something with the no IP domain lookup command, which is saving us a lot of time. Then we're going to go to the local area network card that is connected to the switch. So we say interface fast Ethernet 0/0. This is network A. Network A has a network address of 211.235.0. So we will give it the first IP address on this network, which is 211.235.1. The subnet mask /25 is 255.255.128. And we gotta manually open up the network interface card with the no shutdown command. And when I do this, we see the network interface card is coming alive and the connection to the switch is being made. I will now continue to configure routers B and C. I go to router B, to the command line interface. I say no here, and on this one I will use the abbreviation. So instead of enable, I just say EN. Instead of configure terminal, I say config T. I give it a host name so I know on which router I am working, and I disable DNS lookup on the router. Then I go to the NIC that is connected to the switch. Now this network has network B 211.235.128. The first IP address there is 211.235.129. So here I go. /26 translates to 255.255.255.192, and I say no shut to bring the NIC up, and we see it's coming alive. I go to router C, do the same thing. I say no here, I say en, config T, I name the router, and I disable DNS lookup, so a typo does not have me wait forever. I go to the NIC that is connected to the switch. This is network C, network address there is 211.235.192, so therefore the first IP address there is 211.200.35.193. The /27 is 255.255.255.224. And again I say no shut, and we see now instantaneously the connection is coming alive. The next step, we will give IP addresses to the computers on each location. So we're going to click on PC1 in network A, we click on fast Ethernet here, we go to config, fast Ethernet here, and we add 10 to the first network address that we gave to the router, and so this one will be 35.11. The subnet mask, of course, is 211.255.255.255.128, and then we're going here to set the gateway, which is the router's IP address, 211.235.1. We're going to click on this tab here, click on the command prompt, type ipconfig, and we see, now we're going to ping the router to see if the computer and the router can speak. Here we go, and we see we have good connectivity there. We're going to the second PC, we're going to give him the IP address of 211.235.12. Subnet mask is 255.255.255.128. And again we set the gateway address by clicking here. This is the router's IP address on the fast Ethernet NIC that is connected to the switch. So we click on desktop, command prompt. We test it with the ipconfig command. We took it, we ping the router, and we see the router and the computers are speaking. We will do the same for the PCs on network B. So first I'm going to set the IP address. I add 10 to the first IP address, which was 129, so this will be 211.200.35.139, and the subnet mask here is 255.255.192, 26 bits, and I click on settings to set the IP address of the router as the gateway. So then I test that this is took the ipconfig command, and then I ping the router's IP address. So the computer and the router are speaking. We're going to go to the second PC, configure it, 211.235.140. Subnet mask is 255.255.255.192, and then we're going to go ahead and add the gateway, which is the router's IP address. desktop tab with the command prompt, type ipconfig to see the toke, and then we ping the router to see if the computer and the router are communicating. And that looks good. So we have full communication on the LAN. Time to configure the computers on network C. So we add 10 again to the router's IP address. This will give this an address of 211.235.203, and the subnet mask here is 255.255.224. We add the router's IP address as the gateway. We make sure that the configuration took with the ipconfig command, and it will then ping the router make sure that the computer and the router are speaking. And there we are. Everything is fine. We're going to the last PC. We set the IP address for the NIC. Subnet mask is 255.255.224. And we gotta set the IP address for the router as the gateway. We check that this configuration took with the ipconfig command, and then we will ping the router's IP address to make sure that the router and the computers are speaking. The last step is to connect networks D, E, and F, meaning the connections between the routers. If I hover here, it shows me 00 is connected to 0/1 on from A to C. So, and here on A, I go here, 00 connected to 0/1 on B. So I make this network D, so I go to 00 on this router. Let's say EN, config T, and INT as 0/0. And network D is a network address of 211.235.224. So the first IP address there is 211.235.225, and the subnet mask is of course /30, meaning 255.255.255.252. And this is the site with the timing device, the clock, so we have to put a clock right here. And we then say no shut. This is not open yet because we have not opened it up on router A. Now if I go to router A and I say en config T, interface as 0/1, and I put it on network D, 211.235.226, 255.255.255.252, and I open it up, and lo and behold, we have a connection from router A to router B. We will now configure network E, D is just configured now. E is this connection here. Here we go. It's from the 0, 0 on router A to the 0, 1 on router B. So I go to router A. I type int as 0/0. I give it an IP address on network E, which is 211.235.229, and this is then 255.255.252. Again, I need to provide timing with the clock rate command, and I gotta open up the interface. So now I go to router B, I go to interface S 0/1, I give it an IP address on network E 235.230, 255.255.252, and that's in a shut, and this will then make the connection from A to B. The last step is to configure network F, which is the connection from router B to C. On B it's 0/0, on C it's 0/1, so I go to router B, I go to interface S0/0, I give it an IP address on network F, which is 211.235.233, and a subnet mask of 255.252, and I gotta provide timing on this interface. And even though I open it up, at this point it's not up yet, but when I go to router C, I go to interface S0/1, I give it the corresponding IP address on network F. This one is 234, and 255.255.252, and I open it up, and there we are now. Everything is connected. So we will now test connectivity between the routers. So I press Ctrl C, get out of this mode. Now I'm going to ping router B from router A. So I'm going to ping router B's IP address that is connected to router A. That would be 211.235.230. And here we go, and good connectivity. Now I'm going to ping router C, and here we go. Same thing. So the routers are speaking. Problem is, this computer here can ping its router. And even though the router is connected to router C, it cannot ping router C. There you are. It's not working. Well, the reason for that is the routers need to be aided in finding networks. And we do this with a dynamic routing protocol. We will now configure the dynamic routing protocol OSPF. We begin on router A. We use the enable or en command for short to go to privilege exec mode. Then we use the config T command to go to global configuration mode, and then we're going to configure the OSPF routing protocol. First syntax is router OSPF, then we use a low digit, 2-digit number typically to assign a process ID. This does not have to match from router to router to router. And then we configure all the networks that this router knows about. Network 211.200.35.0, and this is the one where we have a /25 subnet mask. So we use a wildcard mask of 0.0.0, so this must match perfect, and 127. Assign this all to area 0. Then it knows about network, the connection networks. First one is 211.200.35. This is 228. This is a /30, so the wildcard mask is 0.0.0.3, and again we assign it to area 0. And the last connection network it knows about is 232, and the same wildcard mask 0.0.0.3, and we also assign this to area 0. Then we press Ctrl C. We make sure that the router does not forget this information by using the copy run start command, which makes this now permanently. And at this point, when I say show IP route, we will only see the directly connected networks to this router. And we go to router B, and to go to privileged exec mode, config T, we go to global configuration mode, then router, OSPF, and a process ID. Then the networks that router B knows about. This one is network 211.200, and this is 35.128. This has a subnet mask of /26, therefore the wildcard mask will be 0.0.0.63, and again we assign this to area 0. Then the two connection networks this router knows about. Network 211.200.35, this is 228. This is a /30, so the wildcard mask is 0.0.0.3, area 0. There it goes. And the last one, we just use the up arrow key. And we see there's starting to talk now. A message from router A came over, but they are communicating, and the last one is network 232. We again assign a wildcard mask of 0.0.0.3, and again assign this to area 0, and press Ctrl Z, and we make this configuration permanent with a copy start command. And if we now say show IP route, we will see, lo and behold, we have one route, one network advertised via OSPF from router A to router B. So the last step is to configure OSPF and router C. So we go to privileged exec mode, and then to global configuration mode. And we enter the router OSPF command, and assign the process ID of 14, and enter the networks this router knows about. Is one knows about network 211.200.35.192 with a subnet mask of /27, so therefore the wildcard mask will be 0.0.0.31, and again we assign this all to area 0. Then the two connection networks this router knows about. 211.200.35 8.224 is /30 mask, so therefore the wildcard mask will be 0.0.0.3, and again we assign this to area 0, and the last one is network 232. Same /30, same wildcard mask, 0.0.0.3, and again assigned to area 0. Press Control C. We now get a message from the neighboring routers A and B that they have communicated with one another. We make this a permanent configuration. The copy run start command, and now we're going to hopefully display networks advertised via OSPF, and here we see 3 networks have been advertised to this router via OSPF. And we go to B. Before we had 1 network advertised with OSPF, now we have 3 here as well. And we go to A. That this router knows about now. Again, also 3 have been advertised by OSPF. And if you recall previously, we went to this PC and we tried to ping. So let's ping its router. First thing, 211.200.35.1, and it pings this fine. So let's ping the neighbor router, 211.200.35.129. This would be router CB. We can ping router B. And then let's see if we can ping this PC over here. This PC over here has an IP address 211.200.35.140. So let's see if we can ping it here. So we change this to 140, and lo and behold, we should get a answer from this computer, and there we are. We are now completely routing from router to router, computer to computer, complete network connectivity with OSPF.